Welcome back, guys, on the series of solving OAU post UTME past questions. So this question is the next question we're moving on to in the past question. The question says that which is a nucleophile? A, AlBr3, B, Cr2 plus, C, CH3, CH2 double bond CH2, D, B, Br2. So if you're here to get the past question, you can get it, but if you don't have it, just follow the questions through. So the question says which of the following is a nucleophile. So the first thing you need to know is what is a nucleophile, what is an electrophile. So when you're talking about a nucleophile or an electrophile, from the word phile, phile means to love something. So a reagent or an element that loves the nucleus, that is looking for proton, is what we call a nucleophile, while a reagent that is looking for an electron is what we call an electrophile. So electrophiles are defined as electron seeking reagents, while nucleophiles are defined as nucleus or proton seeking reagents. So you know why we're saying this. Imagine hydrogen ion that has lost its electron, is carrying H plus. Now that means that hydrogen lacks electron carrying H plus, and what do you think that hydrogen will be looking for? Electron. So all positive ions are electrophiles. Nucleophiles, those ones that have excess of electrons, that are looking for where to donate that electron, they are called nucleophiles. So what do you think something that has more electron will be looking for? It will be looking for positive places, of course. So it will be looking for where positive charges are more, so they are negative charge ions. So if you're talking about nucleophiles are negative ions. Because another thing is that if you have learned about acid, base and salt, there's what we call Lewis acid and Lewis base. Lewis bases are electron pair donors. When they donate electron pair, what does that mean? That means they have excess electrons, so they are donating it. So Lewis bases are also nucleophile. Lewis acid are electrophiles. So if you look at these options we have here now, AlBr3, it's a Lewis acid. It has a space on top that is yet to be filled with lone pairs of electron. So and what are Lewis acid? Electrophiles. So A cannot be the answer. B is Cr2 plus. Cr2 plus must have lost 2 electrons. So what will it be looking for? Electrons. So that cannot be the answer. All positive ions are electrophiles. Before I move on to C, let's look at D. BeBr2. If you draw the covalent structure of BeBr2, you're going to see that it is also a Lewis acid, because it will be looking for 2 lone pairs of electron. So it is also an electrophile. But if you look at option C has a double bond, and that double bond has a pi electron, which we call pi bond. So those pi electrons are moving everywhere, looking for who to love up with. And that's why they are called nucleophiles, because there is excess electron. So they are looking for who to come and take those electrons. So your correct answer is going to be C. So look at the compound, which one has excess of electron, and that will be your right answer. So these are the other questions on electrophile and nucleophile. If there's anyone you cannot solve, you can let me know in the comment section. I'll solve it with you. So there are question 5, 141, and question 17. So if you have the past question with you, question 5, question 141, and question 17 are questions on electrophiles and nucleophiles. So if you have any issue on this, you can let me know. We'll solve them. And if you're here to subscribe to our channel, please do, as we move on with this question.